In this video, we're going to be doing some more practice with function writing by doing Chapter 6, question number 6. And in this one, the problem is in physics, an object that is in motion is said to have kinetic energy. The following formula can be used to determine the moving object's kinetic energy. And we have the kinetic energy equals 1/2 the mass times the velocity squared. And what those variables are explained in the question there. So we want to write a function named kinetic energy that accepts an object's mass and velocity as arguments. The function is to return the amount of kinetic energy the object has. And we want to demonstrate the function by calling it in a program that asks the user to enter those values. So the first thing we're going to do is start off with our normal boilerplate stuff. We want to include, and we know we're going to want to include IOStream because we're going to be taking an input from the user and printing output. We also want to include using namespace std so that we don't have to prefix all of our couts and cns with std. So let's stub out our main function now, and that takes no parameters and then returns 0. Alright, so let's define our function up here, or declare our function right here. Now we know we want to return a value, and what should we return it as? Given the nature of the question, it's probably best to go ahead and take in and output doubles in case we have decimal places in our input or output. And it tells us specifically that we need to call this function kinetic energy. And the input is mass and velocity, and those will both be doubles. Okay. Now we can actually go ahead and write out the function down here. So again, double kinetic energy. The first argument is going to be the mass, and the second argument is going to be the velocity. So what does this function return? Well, it returns 1/2 times the mass times the velocity squared. Now because we are doing essentially all multiplication, the order of operations isn't that important. It's not important at all because multiplication has the same order of operations as other multiplication. That'll be clear in just a second. So we're going to do 0.5 times the mass times the velocity. Now we want to square it, so that's just velocity times velocity. So just to make it a little easier to read, let's go ahead and put parentheses around these. Now these are not going to affect your answer because again, the order of operations is going to be the same. So 0.5 times mass times velocity squared. Okay. Now we can go ahead and hit run. Nothing's going to happen, but it will tell us if there are any errors. So nothing happened as we expected. There were no errors, so this is good. So let's go ahead and start writing our program. We know we're going to have a couple inputs, so let's declare those now. Mass, velocity, and we also want Ke for kinetic energy, and let's just default those to 0. Let's prompt the user. Enter mass in kilograms. Okay. We're going to put their answer into the mass variable, and again, we're just using numbers. We're not inputting strings, so we don't need to use getLine. Now let's grab the velocity. Enter velocity in meters per second. Cn velocity. Let's go ahead and put a little delimiter here. Now we want to say that the Ke, the kinetic energy, equals, and we want to call our function. And the first value for the function is the mass. Second value for the function is the velocity. Now we can say Ke equals, and then we can just spit out the answer. So let's see what we get here. asking kilograms. Let's say it's 5 kilograms, and let's say it's going 10 meters per second. Its kinetic energy is 250. So just a point I want to make here, and hopefully you saw it in the last video. The way that these values get passed in to this function down here is not by name, it's by the order. So these don't need to be named the same. They happen to be named the same in this one, but we could put, for instance, M and V here. And we would just need to make sure that M and V get passed in the order down here, and it's still going to get the same result. Okay, that's it for this video. As usual, please provide any comments in the discussion area, or hit me up in Canvas under conversations if you have any questions about this video.